a pipe of diameter of 1.5. So I have a diameter equal to 1.5. I don't know if it's a model or prototype. Just keep it. You are going to transport the oil with a pipe. So SG, or a specific gravity, is 0.9. And viscosity is the number that you can see. And the last one says the rate of 3000. If you have no idea what does it mean when it says rate, which is the flow rate, which is discharge, look at the unit, liter per second. Volume, liter is a kind of volume per time. So this is discharge, which is Q. So Q is equal to 3000. Up to now, I assume that I have no idea if it's a model or prototype, but immediately after second sentence, it says tests were conducted. So it means that everything after that is related to test. Test means model. So before that was description of prototype. You can add index of P for all of them. Like the one that I'm going to do. Diameter of P, 1.5 meter. SG of P, 0.9. Viscosity, since it doesn't mention that it's dynamic or kinematic, we agreed that when it just says viscosity, consider its mu. 3.5 poise. And Q of P is 3000 liter per second. Or if you divide it by 1000, you will end up cubic meter per second. That's the first list. I try to write the list always for me here. Test conducted on a diameter of this number. So don't be naive. You should see the model things. You should see, for example, it could be prototype, although it's smaller, but find the word of model or the real one or the prototype or the test. Using water of 20 degree, which is for model. Find the velocity of the model and the discharge of the model. First of all, I have some data that I don't like. Temperature. Temperature is just for you to find the rho. So based on the table from the first chapter, it will give you the rho, which is 1000 kilogram per minute. The other one that I have is this guy and this guy. I probably need this one, but for SG, you know that SG is equal to rho of anything that you have divided by rho of water. 0.9 is equal to rho of oil divided by 1000. So rho of oil is 900 gram per cubic meter. Yes, I think these are the only thing that I can change here. If anything else needed, I will make an adjustment for that. Probably there's a data there. Okay. Now it's time to see which number should I use. What do you think? Weber, Freud, Euler, Mach, Reynolds? Yeah, I put all five. Which one? Is it high velocity? No. So Mach? No. Is it like surface tension is very important? No. Weber? No. Pressure doesn't mention even, you have no idea about the pressure. So Ulerno, just Freud and Reynolds. Which one? Reynolds, it's a pipe. So, and you have viscosity. If you start with Freud, you don't have any idea what to do with the viscosities. So I would say Reynolds of model should be equal to Reynolds of prototype. Rho. V, instead of L, I can use diameter. L is the representative of a length. It doesn't matter. If you have depth, use depth. If you have diameter, use diameter. Divided by mu equal to rho VD divided by prototype, prototype, prototype. Model. I need to find the velocity. So I will keep all the velocities one side, the rest the other side. But you can start putting number immediately after that. Rho of P, D of P of M. I need to find this one. I have velocity somewhere, no? No, so I will keep that one here. Or let me write it that way. I would like to go here. Row of prototype, we have it 900. Row of model, that's water 1000. D of prototype 1.5. D of model, this number. Row of mu of prototype 3.3 multiplied by this one. And I don't have it, I think, but probably, not probably, for sure, based on the temperature, you can find this one. But let me check what's the number for that. I don't have it. So here you have it, table, I will write it. And you have all the numbers except velocity of the prototype. Let me check the solution if I can find a number for that. Yes, that's this number, 1 multiplied by 10. 1 multiplied by 10. Okay. Velocity of prototype. Let me change the color here. So here, Q of prototype is equal to velocity of prototype multiplied by area of prototype. Velocity, this is the only one I need to find. Multiplied by area. Area is a circle. So you have the diameter. And it's not equal, it is equal. So VP, you have it. It's 1.697. 1.697. So find the V of model. You have all the numbers you need. And then Q of M. VM area of M. What's the velocity for model?
I have 5.0 level.
Yes. What's the discharge? And as you can see, velocity in the model is higher. You are modeling in a very smaller version, so velocity is higher. Discharge for sure less than outside. What's the number? Yeah, I have 8, 9, which I think makes sense if you say. First step,